Hello, class. Welcome to Automotive Electrical Inspection and Maintenance class. With the advancement of automotive technology and the continuous improvement of people's living standards, air conditioning is one of the modern symbols and a standard feature of automobiles. In this lesson, we will mainly study the automotive air conditioning system's functions, components, classifications, and features. The primary function of the air conditioning system is to regulate the air inside the vehicle, including temperature, humidity, and air purification. It enhances the comfort of the driver and passengers while improving visibility by preventing fog and frost, ensuring road safety. Key functions of automotive air conditioning include temperature regulation. Adjusting the interior temperature is the fundamental function of automotive air conditioning. Humidity control. Typically, humidity control involves reducing humidity. This is achieved by condensing water vapor from the air onto the evaporator surface and then draining it outside the vehicle. Airflow adjustment. The speed and direction of airflow have a significant impact on human comfort. Air purification. Keeping the air clean is essential as prolonged closure of windows and doors can affect air purity, which in turn impacts passenger comfort. Unpleasant odors must be removed. The components of an air conditioning system include refrigeration system, heating system, ventilation system, air purification system, and control system. The function of the refrigeration system is to lower the cabin temperature when the external environment is hot, providing passengers with a cool and comfortable atmosphere. The automotive air conditioning refrigeration system comprises components such as compressor, condenser, evaporator, expansion valve, liquid storage dryer, refrigerant lines, cooling fans, and a control system. The heating system is responsible for heating the cabin air or fresh external air entering the vehicle, providing warmth and defrosting. The ventilation system's purpose is to draw fresh external air into the cabin while driving, continuously introducing fresh air and expelling harmful gases. It primarily consists of components such as a blower, air intake port, distribution outlets, and air ducts. The air purification system filters the incoming air to maintain clean air in the vehicle. There are typically two types: air filtration and electrostatic dust removal. Electrostatic dust removal may involve a separate unit or additional equipment integrated at the air intake port. The control system primarily serves two purposes. Firstly, it controls the temperature and pressure of the refrigeration and heating systems. Secondly, it controls the temperature, airflow direction to optimize the various functions of the air conditioning system. It is composed of sensors, switch signals, air conditioning amplifiers, and executive components. Key control aspects include compressor, electromagnetic clutch, evaporator, temperature control, pressure control, cooling fan control, blower control, and other protection controls. Single function refers to having only a cooling or heating device and is mainly installed in vehicles that operate in hot or cold regions year-round. Integrated cooling and heating refer to the sharing of a blower and control mechanism for both cooling and heating air. Based on the driving method, it can be classified into independent and non-independent air conditioning systems. An independent air conditioning system is powered by a dedicated power source, operate the entire air conditioning system. The advantages include minimal interaction between cooling and driving, higher cooling capacity, and stable cooling performance. The downside is its complex structure, relatively high cost, higher noise levels, and installation challenges. Non-independent air conditioning directly utilizes the vehicle's engine to run the system. The compressor is operated by the engine and controlled by an electromagnetic clutch. When power is supplied, the electromagnetic clutch engages, causing the compressor to run for cooling. When power is cut, the electromagnetic clutch disengages, and the compressor stops, achieving control over the vehicle's temperature. The advantages include a simple structure, ease of installation, and low noise levels. The disadvantage is that it consumes engine power, reducing the vehicle's available power and affecting its performance. Based on the control method, air conditioning can be categorized into manual air conditioning, semi-automatic air conditioning, and automatic air conditioning. In manual air conditioning, only rough adjustments of cold or hot air temperature and airflow can be made, and specific interior temperatures cannot be set. The advantages of manual air conditioning are cost effectiveness, mechanical simplicity, and a straightforward structure. The disadvantages include a heavy load and imprecise temperature control. Drivers and passengers manipulate knobs and buttons on the electric control panel, which then translates their commands into electrical signals. These signals are sent to the actuators, controlling the operation of the air doors and regulating processes like air intake, temperature delivery, and air distribution. The advantages of this system include low manipulation load, a simple appearance, easy operation, reliable control with independent actuators, and moderate cost. However, it has the disadvantage of being unresponsive to environmental changes, lacking precise temperature control, and the inability to maintain a consistent temperature. In contrast, automatic air conditioning can precisely set the temperature, achieving and maintaining the desired interior temperature. It can also automatically adjust fan speed, as well as control the operation of the fresh air mode motor, air blending mode motor, air delivery mode motor, and the compressor when external environment conditions change. Precise temperature control has the advantage of intelligent and consistent temperature regulation, providing excellent comfort and visual operation and control. It also has a low manipulation load. However, the disadvantages are its high cost and the complexity of maintenance. Based on the air delivery method, there is direct blow air conditioner. Its airflow is directly blown out from the air outlet panel. This design is simple but results in poor air distribution. Non-independent air conditioning systems typically use this method. Wind tunnel air conditioners transport the air through a fan to a duct and then to the air outlet for distribution. This method results in more even airflow, but has a more complex structure. Independent air conditioning systems typically use this approach. In terms of the layout, there are integral air conditioning systems, which combine components like the auxiliary engine, compressor, condenser, and evaporator into a single unit using belts and pipes. Split air conditioning systems arrange components like the compressor, condenser, evaporator, and the auxiliary engine of the independent air conditioning system. According to the specific vehicle structure, these components may be partially or entirely separated and interconnected through pipelines. Fan type air conditioning systems distribute various components like the compressor, condenser, and evaporator in separate locations, interconnected through pipelines. The choice of an air conditioning system for a car depends on the vehicle's operating environment and specific requirements, especially its ability to adapt to harsh conditions. Generally speaking, automotive air conditioning systems should possess the following features. First, strong cooling and heating capabilities. Second, robust resistance to impact. Third, versatility in power sources. Fourth, compact structure. This concludes all the content of this lesson. Thank you for watching.